Membrane cholesterol depletion and ion transport. Quoted from the article How Statins Really Work Explains Why They Don't Really Work by Stephanie Seneff from MIT. Quoting, as I alluded to earlier, statin drugs interfere with the ability of muscles to contract through the depletion of membrane cholesterol. Haynes has argued that the most important role of cholesterol in cell membranes is the inhibition of leaks of small ions, most notably sodium and potassium. These two ions are essential for movements, and indeed cholesterol, which is absent in plants, is the key molecule that permits mobility in animals through its strong control over ion leakage of these molecules across cell walls. By protecting the cell from ion leaks, cholesterol greatly reduces the amount of energy the cell needs to invest in keeping the ions on the right side of the membrane. There is a widespread misconception that lactic acidosis, a condition that can arise when muscles are worked to exhaustion, is due to lactic acid synthesis. The actual story is the exact opposite. The acid buildup is due to the excess breakdown of ATP to ADP to produce energy to support muscle contraction. When the mitochondria can't keep up with energy consumption by renewing the ATP, the production of lactate becomes absolutely necessary to prevent acidosis. In the case of statin therapy, excessive leaks due to insufficient membrane cholesterol require more energy to correct, and all the while the mitochondria are producing less energy. In vitro studies of phospholipid membranes, it has been shown that the removal of cholesterol from the membrane leads to a 19-fold increase in the rate of potassium leaks through the membrane. Sodium is affected to a lesser degree, but still by a factor of 3. Through ATP-gated potassium and sodium channels, cells maintain a strong disequilibrium across their cell wall for these two ions, with sodium being kept out and potassium being held inside. This ion gradient is what energizes muscle movement. When the membrane is depleted in cholesterol, the cell has to burn up substantially more ATP to fight against the steady leakage of both ions. With cholesterol depletion due to statins, this is the energy it doesn't have because the mitochondria are impaired in energy generation due to coenzyme Q10 depletion. Muscle contraction itself causes potassium loss, which further compounds the leak problem introduced by the statins, and the potassium loss due to contraction contributes significantly to muscle fatigue. Of course, muscles with insufficient cholesterol in their membranes lose potassium even faster. Statins make the muscles much more vulnerable to acidosis, both because their mitochondria are dysfunctional and because of an increase in ion leaks across their membranes. This is likely why athletes are more susceptible to muscle damage from statins. Their muscles are doubly challenged both by the statin drug and the exercise. An experiment with rat soleus muscles in vitro showed that lactate added to the medium was able to almost fully recover the force loss due to potassium loss. Thus, production and release of lactate becomes essential when potassium is lost to the medium. The loss of strength in muscle supporting joints can lead to sudden uncoordinated movements, overstressing the joints and causing arthritis. In fact, our studies on statin side effects revealed a very strong correlation with arthritis, as shown in the table. While I am unaware of a study involving muscle cell ion leaks and stains, a study on red blood cells and platelets has shown that there is a substantial increase in the sodium and potassium pump activity after just a month on a modest 10 milligrams of statin dosage, with a concurrent decrease in the amount of cholesterol in the membranes of these cells. This increased pump activity necessitated by membrane leaks would require additional ATP and thus consume extra energy. Muscle fibers are characterized along a spectrum by the degree to which they utilize aerobic versus anaerobic metabolism. The muscle fibers that are most strongly damaged by statins are the ones that specialize in anaerobic metabolism. These fibers, type 2B, have very few mitochondria as contrasted with the abundant supply of mitochondria in the fully aerobic type 1A fibers. I suspect their vulnerability is due to the fact that they carry a much larger burden of generating ATP to fuel the muscle contraction and to produce an abundance of lactate, a product of anaerobic metabolism. They are tasked with both energizing not only themselves but also the defective aerobic fibers due to the mitochondrial dysfunction and producing enough lactate to offset the acidosis developing as a consequence of widespread ATP shortages. In the next video, we will explore the effects of long-term statin use.